session, we have two speakers, Vishal and Byron Chu. Byron has a PhD in biochemistry and is a certified project manager. In his current role at Cybera, not only manages projects, but also works with data and delivers technology training to Albertans of all ages. His proudest achievement at Cybera has been working with Callisto, building fiber networks and helping Albertans get started with data science. If he's not at his desk, you will find him running or spending time with his family. Vishal is a data scientist at Cybera. He develops machine learning and predictive forecasting solutions to model the Alberta labor market using job postings data. His everyday work at Cybera involves closely working with full stack developers, which made him specialize in building uh, machine learning and data science prototypes, including analytical dashboards on a remote cloud server. He has mentored data science project helping SMEs in Alberta with tools to better leverage the data. He has a master's in chemical engineering from the University of Alberta. If he's not in his desk, you will find him playing squash or jogging along Edmonton's scenic River Valley. Let's give them a round of applause. Thank you.
Hey everyone. Okay, first of all, I just want to thank some of our supporters of our Applied Data Science Lab, which we'll be talking about in a second, so Alberta Innovates and TraceCAD. Today, we'll start with some introductions, give you some context about what we're talking about, and what Vishal will be demoing, and then Vishal is going to take over and just walk you through the workshop today. A little bit about Cybera. Maybe a show of hands. Has anyone here heard of Cybera in the crowd? All right, not bad, not bad. Okay, so Cybera is a non-profit IT company, and we do a variety of different things. So for the past 30 years, we've been running the Research and Education Network here at the bottom. And in the past 15 or so years, we've been running our own cloud environment called the Rapid Access Cloud. And so we have a free public cloud for anyone in Alberta to use. And ever since we got the cloud up and running, we've delivered services off that cloud and also delivered data science training and solutions from that cloud as well. So we also help the private sector through these initiatives as well, not just the public sector. So a little bit about the Applied Data Science Lab. What we do and what we deliver are industry cohorts, so that's kind of talent development. So we have internships for people who are looking to break into data science. We also work with companies or SMEs, local SMEs, so Alberta-based small, medium-sized enterprises, and we get them started on the first data science projects and first data science product development work. We also run community events or involved in community events such as hackathons and workshops, such as the one today. And we also really promote open source data science tools such as cloud computing resources and our Rapid Access Cloud and other tools that are useful to data scientists. Okay, just a little bit about the Applied Data Science Lab industry cohorts. So kind of where our sweet spot is the discover stage, the experiment stage, and the implementation stage of developing your data science projects. And so that involves developing proof of concept work, prototyping work, and then the dotted box is around sort of like scaling your prototype work. So that's something we're hoping to also do a little bit more, and depending on the project, we also try to do a little bit more with the companies. So that's kind of our sweet spot. And based on if any of you attended the keynote this morning with Alex, he mentioned a lot about data ops and sort of like the scale of going from to production with your machine learning models. So there's a bit of a gap between prototyping and production machine learning, and so I think we can learn a lot together, especially if you're working with us, on how to kind of bridge that gap as well. So we're not, we don't profess to be experts in this area, but we definitely want to learn along with you in the journey to production. Okay, a little bit about today's workshop. So I just did a quick Google Trends search yesterday or 2 days ago around the word ChatGPT. And so this, if you're familiar with Google Trends, it's relative search interest. So if you put in ChatGPT, you'll see a huge spike around, well, a big spike around December, and then since January, it's really kind of taken off. So, a lot of interest, like general public interest in ChatGPT and what it can do and how it can help you and how it can, change your lives, really. But maybe what's not obvious is if you look, in the blank space where there is no relative interest, there's been a lot of stuff happening behind the scenes or under the hood for a number of years that led to the development of applications such as ChatGPT. One of those developments and emergence, or it's an emerging paradigm known as foundation models. So foundation models are basically models, example BERT, DALI, GPT-3, trained on broad data, generally using self-supervision at scale, that can be adapted to a wide range of downstream tasks. So this is a term or paradigm coined by the Stanford Institute of Human-Centered Artificial Intelligence. And the emergence of this term is really due to a couple of factors. So one they describe as homogenization, so homogenization of methods to develop these machine learning systems, and then also the emergence of new functionalities, new behaviors from the machine learning models as well. I guess one important thing to note is that these foundation models are not just large language models. They take as input, photos, videos, sensor information, and knowledge data. So I come from a biochemistry background, so understanding molecules and stuff like that. And so it can take inputs from all these different sources to generate insights. And new insights as well, I guess that's the key part. And so maybe one example of kind of this new multimodal type of model is GPT-4, which can take as input both images and text, for example. I guess the other thing I also want to mention today is, we're not going to be using these specific foundational models today, but the idea is to really get hands-on and build and deploy with these models. So it's something where, we don't want it to be something abstract where you can't really touch it. You actually want to be able to interact and use it. And so one of the reasons why we're doing the workshop today is actually to show you, even if you want to experiment with these things, you can actually start to do it today using open source tools and actually with your laptop as well. So with that, hopefully I set you up for your workshop today, and so Vishal is going to take over.
Thank you, Byron. I have a live demo planned, so I'm going to put the mic on the holder before Okay, all good. Excellent. Hope you can hear me all right. Okay, fantastic. So thank you, Byron, for introducing all of us to Applied Data Science Lab program at Cybera and briefly touching on foundation models. Now we are going to switch gears a bit and focus specifically on text-to-image, a stable diffusion model. As the name implies, text-to-image, these foundational large pre-trained models can take in text input or a prompt and outputs a photorealistic image. These are developed by the researchers and engineers from Stability AI, Compass, and Lab. If you go back, I think 3-4 months ago, I think when DALI 2 and Midjourney, when you're able to generate these arts using prompt, I think all of us got really excited and we're all using it. And this specific workshop, we are going to be leveraging a model from Hugging Face. Hugging Face, for those who don't know, they claim themselves as they're on a mission to democratize AI, and they're kind of a hub. They have access to all the open source models, data sets, and such. So this specific workshop, we are going to be using one of their libraries, diffusers, and using the library, we are going to see how it works and how you can take that and deploy it adapt it for your use case. And there are a lot of libraries supported in diffusers pipeline, and this link provides more models about this, and you can read more about it on their official documentation. And yeah, so moving on. Before we go to the model deployment, if you look at the traditional model development process, traditionally it has been data scientists would typically develop something on their local computer or a personal computer or a work computer. So while this is good, it's all localized, it's sitting on their own personal or a work computer. As you could see, there is no proper dependency management. when you develop something, when you train, test, validate something, and when you find it promising, when you hand that off to the development team to deploy it on a server, it's usually sending it on a Jupyter notebook. You put the notebook on a GitHub repository and sending it to the development team. While this is good, but obviously, as you could see here, you haven't really made sure the environment is the same, the packages are not maintained properly, so this is bound to failure. This is bound to fail. And oftentimes, the data science team has limited control with the data, overall deployment lifecycle. And instead, so once the development team takes over, they would typically deploy it on a server and then serve it up with some APIs, like Flask, for instance, and some containerization tool, and then some front-end framework so that clients could use it. Some of the tools that I mentioned here, like the Postgres database, these are just for illustrative purposes, but it could be any of those tools for APIs, for database, and for for front-end framework. Now instead, so what we propose and what teams have started doing now is, what if we could take some of the development practices and incorporate much earlier in the data science lifecycle? So if I go back and forth, the only change that you're seeing is the data science team. So now, rather than doing it locally on your personal laptop or your work computer, now you're actually doing it on a remote cloud server. And with remote cloud server, you're also using some containerization Docker principles, which will really allow you to manage your packages and helps you to ship your product to the development team in a more completed fashion. And the fast API is really gaining in importance, and we're going to see how you can turn a model into a simple API so that anyone could send a post request or a get request and get the model output back. And also have a Streamlit in here because Streamlit is again gaining in really popularity. If you want to serve a simple dashboard, a simple user interface, it's all Python framework. You could spin up a simple Streamlit container, and it's going to serve it for you. And as you could see here, rather than shipping a notebook, you're going to ship it as a Docker service or Docker container. Now, the development team is more set for success. Now, it's easier for them to translate the model that you made or developed to a workable code. That's what proposed model development process. Now, let's move on to the demo now. Before that, I'd like to briefly touch on, as I mentioned now, we're living in the exciting times of AI now. With each day, with each week, we have a lot of exciting news development happening. In fact, a couple of days ago, GPT-4, I think, they have their own development API access to. So we are going to be having much more in the future as well. So how can we leverage these models and adapt it to our framework? So in our demo, I'm going to be demoing from my laptop. So it has Visual Studio Code installed. I personally like Visual Studio Code because it has a lot of extensions which really make your development process much easier. So once I have the Visual Studio Code, I'm going to connect it to a cloud server. I have a GPU enabled cloud server, but right from the time I joined in Cybera has been one of the great things that happened to me is I moved away from local development to doing everything remotely. So I don't have Python installed on my laptop. I don't have any software tools that I'm going to demo today on my laptop. Instead, everything is on my cloud server. And now after that, I'm going to show you Hugging Face. How can you pick a text to image model and how can you run it on a Jupyter Lab notebook and see how it really functions. And once we find it promising, then we are going to develop a FastAPI, an API endpoint. Basically, it's going to accept GET requests. It's going to take in requests and send you the image as the output. Once we have the API, the next obvious step would be to build the interface. And we are going to see how can we develop an interface using a Streamlit app. And the great thing, it's all going to be on a Docker container. So if you're going to ship it to the development team, it's all encapsulated, it's all an isolated environment. It's really easy to transfer it say if you're sending it to a colleague or if you're sending it to a different team, it's really easier because it's all packaged on a single container. Yeah, fantastic. So now, quickly on cloud services, because I touched upon cloud service. Um, Outside of the commercial cloud vendors, we have Rapid Access Cloud, which is from Cybera, the company that I work for. So it's freely available. The great thing with this is freely available to anyone in Alberta for non-commercial purposes. So if you're looking to experiment, if you're looking to run if you're looking to train a machine learning model, I would highly encourage to sign up here and then build your first machine learning model on a remote cloud server. It's majorly aimed at for prototyping, and it's nothing but infrastructure as service. That's what it makes it possible. And part of the presentation that I'm going to do, we also developed in Isaac, our partners. If you're a company, if you're an SME looking for some computational resources for your team, I'd highly encourage you to contact them. They're a Western Canadian company offering cloud resources for the SMEs. They're client forced service offering, so based on your needs, they would customize the cloud resources for you. So those are some of the options. And quickly introducing you to Docker. Again, Docker is something that I really like using right from the first day that I joined Cybera, and I still miss why didn't I learn this much earlier, because it makes your job a lot easier. In fact, it might take a little bit of a learning curve initially, but I would highly encourage you to go through that because it would make your job a lot easier moving on. And it becomes so comfortable that if I want to do anything, all I do is spin up a Docker container and work on it. Yeah, so speaking of Docker, it's an open platform for developing, shipping, and running applications. Again, the main aim of Docker is it reduces the delay between writing a code and scaling up to the production. That's the important thing here. And how it really works is every Docker container begins as a blank Linux virtual machine, and then you instruct the Docker through Dockerfile to tell what dependencies need to be downloaded and what needs to be installed and what needs to be run. Please don't worry if you don't understand everything. I'll touch upon it later in this presentation too. And all this will be written in a file called Dockerfile. Okay, so why do data scientists need to care about this? Because it automates the boring stuff. And then reproducibility, that's one of the major factors. You develop something and you're sending it to someone. Oftentimes they have different environment and then you run into issues, so it reduces that. And then fast and consistent delivery of application. And then my favorite one is responsive deployment scaling. Really helps you to scale up from prototyping to all the way to production. And it helps you to run different workloads on the same hardware. And if you're developing something in Python, you don't need to have Python installed on your host machine. It's okay to have in the container, and that's all you're set to go. Okay, great. So again, this I wouldn't go in detail, but we are going to demo how can you spin up a Jupyter lab. It's nothing but a web-based interactive development environment for notebooks, code, and data. Okay, great. So now I'll jump out of the demo. What I'm going to do is I'm going to open a Visual Studio Code, and I'm connected to a cloud server that I already set it up. And then I'm going to take one of the Hugging Face text-to-image pre-trained model and going to quickly run it on a Jupyter Lab Docker container. So I'll quickly go back. Hopefully everything was good. Open Visual Studio Code. So as I mentioned, real good thing about Visual Studio Code is it's got an array of extensions which would make a job as a developer or data scientist a lot easier. So specifically for this, I would be using remote SSH. That's extension supported officially by Microsoft. So once you install it, you would see on the bottom left, that's the extension, and I'm going to click it. I'm going to say connect to host. And these are the instances that I already have. Based on my projects, based on my use cases, I have about 6 to 8 instances currently running. I'm going to connect to the first instance here, which is a GPU instance. And as you could see, it just seamlessly you're onto the container, onto the remote instance now. How do you know that? Because on the bottom left, you see you're on an instance. Now I'm going to open a folder called text to image. Again, all the codes that I'm going to demo today, I would tell the link to the GitHub repo towards the end of the presentation, so you don't really have to worry about the details. Okay, so here I have a README in here. I'm just going to quickly show you. Yeah, so the main requirements, you need to have an Ubuntu server, not specifically this version, but some Ubuntu server. And then, as you know, if you're running some GPU based tasks, you need to have these drivers CUDA installed for you to access the GPU. And then the only two requirements is Docker and Docker Compose. That's all you need on your virtual machine. You don't need to have Python or any other packages installed on your host machine. Once you have that, you're all set to go. I installed already all of these requirements before, so I'm not going to do it now. Just to quickly confirm, I would say Docker version. That's, you have a version here, and then Docker Compose version. You have a specific Docker Compose version here. Again, you don't need to have this version, but you need to have some Docker version just supported by the CUDA drivers. Okay, fantastic. So now the main portion here, go to the Docker Compose file. So Docker Compose is nothing but it is a YAML file where you configure different containers. So I'll start with the first set here. This is nothing but a Jupyter Lab. Maybe I'll blow up the screen a bit. So this is a Jupyter Lab container, and the user is root, and then build. This is the main portion of this Docker Compose file. You're setting the context, and you're setting the path to the Docker file. So the context is Docker Jupyter Lab. So what it means is that I have a folder called Docker. Inside Docker, I have something called Jupyter Lab. Inside Jupyter Lab, I have a file called Docker file, which is I have already made this for you. So in Docker file, this is really important. Docker file, as we saw on the slide, this is where you instruct Docker what needs to be installed during a Docker build. And I have a specific image mentioned here. So Docker hosts a lot of images. If you just Google this, Docker GPU. Yeah, so this image, this is a Docker Hub. Docker Hub is nothing but similar to GitHub. It hosts different images that users have built, both official ones and the ones that you do it, and then you can upload it as a user as well. So I specifically chose this image for Jupyter Lab because I'm going to be using GPUs through my notebook. So I need this image to build my Docker container and access the running code using GPU. And if you don't have GPU and if you want a simple CPU image, all you would do is Docker Jupyter Lab image. Okay, this is Jupyter Hub. Okay, so this is Docker image. So the documentation has different, okay, it's showing the hub, but yeah, so the idea is that you can pick based on the use case. Since I'm using GPU, I picked up this image, but if you have a CPU, a lot of other images out there, which would make a deployment easier. Now, I need to specify that, as you could see here, there are tags based on the version of CUDA that you have on your system, as well as the Ubuntu version that you have. You need to pick the right tag in here. So for me, the right tag is this image, and I'm just going to say Python only. And then when I run this Docker file, what it does is that it goes to this remote repository, it pulls that image and stores it on and downloads it onto your host machine. After it does that, it's going to copy a file called requirements. And if you look at the same folder, I have a requirements file which has different packages like diffusers, transformers. These are Hugging Face libraries which you would be using in a notebook. So what's really happening is you're copying the requirements file and you're installing, obviously you're upgrading pip first and then installing the requirements on the Docker container. So these are all things happening. Now we're going to spin the container now. So since I have Docker Compose file already, okay, maybe I'll go through the other ports. So by default, as you know, the Jupyter Lab runs in port 8888. We are going to do port forwarding. This is going to run inside the Docker container. So we need to expose this port from the Docker container to your host machine. So that's what's happening here. And then this set of lines is to really enable Docker to use the GPU of your host machine. And then the volumes, again, this is important. The volumes is nothing but you're mounting a folder from your host machine. In this case, I'm mounting the folder notebooks. I'm mounting it to the folder home Jovian work. This is the default folder inside the container. So I'm kind of mounting one to the other so that whatever I do on this folder, it's going to reflect on the container, and whatever I do on the container, it's going to reflect on your host machine. And there are some environment variables. These are just to enable Jupyter Lab. And auth token, I would go to this later, but for you to run a Hugging Face library, you need to have an access token. There are more information on how can you get that on the README and also on the notebook. You can get it on the Hugging Face website. So I'm just sending it as an environment variable. I have it as stored in environment in file. I'm not going to show here, but it's all in there. Once I source it and build the container, it's going to get passed onto the container. Okay, so I'm going to build the container now. So all I'm going to do is first source the end file to get the auth token. And then all I would do is Docker compose up. I'm going to say Jupyter Lab because Docker compose up, we are spinning up the container and the name of the service is Jupyter Lab. When you click enter, so it's going to spin up, and an important thing is that I have this image already stored on my host machine. Before this workshop, I made sure to download because it takes a while because as you could see, it's a large image. So I want to save some time, so I did it already. But if you're doing it for the first time, you would notice it connects to the Docker Hub and downloads the image onto your host machine. Okay, it's running now. Fantastic. Now I'm going to go to the port. So currently it's running on a remote server on port 888. So now for you to access from your laptop, you need to port forward from your remote server to your local machine. That's what's happening here. I'm forwarding the port 8888 to the local address, which is localhost 8. So I'm just going to click this. So it's going to open the Jupyter Lab for you. It's open and nice. And you have a notebook in there already. So this is a text to image library. And all I did is this notebook is entirely based on this block that's from Hugging Face. So again, if you don't get everything that's mentioned here, you can always go through this block. But the idea is that I'll quickly go through what the notebook is. So this checks if the container is able to access the GPU. And then you're going to import some packages. As you could see, the diffusers is the main package that you're going to use. Oops. Hope everything's good. Yeah, fantastic. So diffusers, again, they have access to different text to image pipelines that you want to use. Specifically here, I'm going to use the stable diffusion one. Again, you could go back and pick any of the models that of your choice and use it for your use case. And moving on, again, the model ID, it's randomly pick this model ID. You can go and pick any model supported by diffusers library from the list here. So that's the model ID, and then I'm sourcing the token here. Again, the token, if you want more information, that's a link. And then to set this pipeline, again, if you go through the block, they explain you in detail how this model works and how can you set a pipeline. And to run a pipeline, all you need to do is you need to say stable diffusion pipeline from pre-trained. It's going to download the model weights and put it on your host machine. Again, I'm not going to run, just to show you, and I'm transferring the pipe to the CUDA to make use of GPU. And now with a simple prompt like a photograph of an astronaut riding a horse, you get this nice little image. Similarly, you could change, as you know, with these machine learning models, whenever for the same input, you would end up getting different images each time. So if you want the same static image, you can set the manual seed to be a specific value and then get that same image output. Yeah, so those are some high-level information. This is not a workshop about generative AI, but to show you how easy it is to spin up a container and again, all the codes that I showed you, it's all in the blog, all in the official documentation. You could take those and put it on your container. What we have done different is that we have it running on a Docker container. So that's the first step. The next but important step is and also while we do that, I'll quickly show you about the Hugging Face. Really like Hugging Face because if you go to the Hugging Face and if you go to models, and if I say text to image, a lot of these models out there. I chose, I think, Stable Diffusion v4. And again, you have documentation about what this is and how can you run it on your machine. So all I did is take this code, put it on a Jupyter Lab container. And you would find more details about, if you're looking for more details about the stable diffusion, highly encourage you to look at the documentation here. Okay, fantastic. Now moving on. So now we spun up a Jupyter Lab container and we found something promising. The next step would be to how can you build a simple API so that, say, if you're hosting it, if someone wants to access it. So oftentimes what will really happen is you take some model from Hugging Face or take any model and you adapt it to your use case, that the concept called transfer learning. So for that to do, I really like FastAPI. It's really gaining an importance now. We see a lot of teams development, especially in machine learning community, using it. It's very cool. It's all in Python. And for us to do in Docker, I'm going to show you how I did it. So going to the Docker Compose file again. So we are done with Jupyter Lab. Then we have a next service called FastAPI. So this FastAPI, again the same build. I'm setting the context to Docker and FastAPI. So inside Docker folder, there's a FastAPI folder, subfolder, and there's a Docker file. And if you look at this Docker file again, I use a different image now. Since we no longer need the interface, Jupyter Lab interface, now all I need is a Python which has PyTorch pre-installed. So I went back and looked and I thought this could be a good image. Again, you could use any image that you want. I just chose this image officially from PyTorch and I'm using it for my use case. Again, the tag that you see here is based on my instance drivers that I installed. And I'm setting the work directory and then similarly I'm copying the requirements file. If you see the requirements file, now install in FastAPI. Okay, now you have a basic Python image which has PyTorch. I'm installing FastAPI and I'm installing all other Hugging Face libraries which you would need for spinning up a uh, simple text to image model. Okay, for this quickly, while I show you, I'll quickly run this. So again, I'm going to source the end file because the FastAPI would also need the access token for it to download the image, download the model pre-weights, and then be able to make some inference. Now I'm going to do Docker Compose up. Rather than Jupyter Lab that was in previous case, I'm going to pick the name. Okay, I'm going to quickly look for the Docker Compose file. Okay, it's FastAPI, and then enter. Okay, so it's attaching now. Again, it's not downloading the image; it's already done. What instead it'll do is it'll try to run the pipeline for you. So it's downloading the weights and it's setting up the pipeline. Quickly go through what it does here. Again, the ports is 8000, 8000. That's the default port of a FastAPI container. And again, it needs GPU. So that's what these lines of code does. And volumes, I have a new folder called API. Inside, I'm just mounting this folder to the Docker container. So inside API, I have a main.py file. So this is how you initiate an FastAPI. You import the FastAPI package, and then call the FastAPI package and the FastAPI class, and then this is how you declare a simple GET request. So this request it has a endpoint / text to image, and it is a simple function. It just calls the run stable diffusion pipeline. If I go and look at the pipeline, this is what we saw on the official documentation. I'm just specifying the model ID, specifying the token, and I'm importing the weights from the pre-trained packages, and then I'm transferring it to the coder so that it uses GPU. All it does now is just run this, make prompts to it, and then be able to return return the image based on the prompt. For you to access this, I'm going to, again, this is currently running in port 8000. So I'm going to click this. So one of the great things with API, FastAPI, is it creates an interactive documentation. So once it's running, if I just say /docs, it's going to show you what endpoints are currently available from this FastAPI service. And we have /text to image that we just created from this file in here. So outside of that, you can also see what it accepts. It takes in prompt, and these are some of the additional arguments that go into it. This is required again based on your use cases. You can tweak it, and now I can also say try it out. And just for consistency, I'm going to pick the same prompt that's used in the official documentation. Okay, just going to copy this. Oops. And then I'm just going to execute. So in real time, if you could see the VS Code terminal, it's making a request here. It says OK, and then it outputs a value for you. As you could see, it made some inference and then it giving an output. And if you go back and see, and this is the output that we have. So yeah, it's how easy it is to take. I know the image is a little stuff, but the whole idea is how can you take an input, but how can you make some prompts? How can you use an API to get the output image? It's all it's a great thing. It's now since you're hosting it on yourself using a fast API, you have more control about how the model is performing and what you can do to change the model parameters. So we are done with everything but the last step. So API is done. Now the final thing is how can you now take this API endpoint, serve it on a simple user interface, and serve it to users or stakeholders. I personally like Streamlit a lot. I've been using it for a while now, since before it got acquired by Snowflake. It's really cool. I would highly encourage for those who use to spin up a simple Streamlit app for all of your machine learning use case. Yeah, maybe I'll jump to the demo directly. Now we are going to take the request. We are going to make request to the FastAPI container from the Streamlit app. Again, so you have a new service called Streamlit, similar to what we saw before. I'm setting a build context here, which is Docker Streamlit. I'm going to Docker. That's a Streamlit. That's a Docker file. And in this, I'm just using a simple Python image, Python 3.11 in this case. So what it does, when I spin up this container, it's going to download, put it on a host machine. It's going to set the work directory, and it's going to copy the requirements and install the requirements. If you see the requirements, I'm installing Streamlit, Plotly, and for formatting, I like black, so I use black. So it's all that's needed. I'm not going to install any of those transformers, Hugging Face libraries, because we're going to make requests to the FastAPI container, which already has everything pre-installed. Okay, so that's everything, and it's going to be running on the port 8501. And the one difference that you would notice, it doesn't use the GPU, because all it does is that it's going to just make some requests. That's all it does. You don't need GPU for this container. So I'm going to add another terminal. Just going to say Docker compose Streamlit. That's the name of the service. Again, I download the image already, so it's going to. So every time you spin up a container, it'll first look if you have that image already on your host machine. If you don't have it, it'll go to the Docker Hub and pull that image and downloads it and makes it ready for you to use. Now it's done. It's currently running at port 8501 app. So again, I need to do port forwarding so that I can access it from my local host, and I would just say, and you have a nice little user interface from where you can make requests, and when you do some requests here, it's going to make requests to the FastAPI container, and what are the output it returns, it's going to get back to you. And these are some of the Streamlit input widgets. There are a whole array of widgets. If you just say Streamlit input widgets, based on your use cases, based on how interactive do you want, you can choose from any of these wide array of different widgets. And for this, I specifically chose a slider and a normal input box. But again, based on your use case, you could choose anything. Again, just for the same consistency, I'm just going to grab the same thing here. Since I set the seed to be same, you might notice the same image. Now when I set submit, it's going to, I'll quickly show you how it is. So volumes is app. If I go to app.py, so all I'm doing is importing Streamlit package, and I'm setting the title or info or whatnot. And if you scroll down, all it's making is making a get request to the FastAPI container that's already running. The prompt is the prompt that I just did. And these inference steps, I didn't change it, but you can go back and change it and see how it varies. And again, you saw the same image that you saw here as an output. So the whole idea is to show you how can you go from a simple prototyping or simple exploration to all the way to developing an API. And then once you have an API running, the next step is you don't need to have an experience in any of the JavaScript framework. If at least for prototyping, you can use a simple Python framework to spin up a simple interface like this. Yeah, so that's pretty much my demo. But the overall goal for this is, I personally believe data scientists who have some knowledge on these software development tools or practices would really help speed up the overall cycle of model deployment. So I would highly encourage you to have a look at these tools, have some understanding, and really help you speed up your whole model deployment lifecycle. And that's kind of what I had for today's demo. And if you're looking for more resources, I like this first link on setting up. If you have a blank Linux server, if you're looking for ways to how do you set up necessary GPU drivers, this article is really good. And also, once you have Docker installed, you need to configure Docker to use GPU. And they go through steps. How can you do this in this first link here? And then I went through this stable diffusion with diffusers blog. All the codes that I showed you today, or everything is available in this blog. And the FastAPI, I really like deeplearning.ai. They have some great webinars on different machine learning tools and frameworks. And one of the recent ones was FastAPI for machine learning. I would highly encourage you to watch that as well. It's really good. The founder goes through how can you make some simple requests from FastAPI. And that's pretty much it. And all this would not have been possible without the support from Alberta Innovates and Fraley's Economic Development Canada. And thank you so much for your time. And here's the link to the GitHub repository that I just demoed with. Thank you. Thank you. Yeah. Any questions? Yeah, please go ahead.
Great presentation. I really liked